All right, we're back for 2012. This is A, B, and BC, number 5. So this is the problem. So the previous year they did the very, very similar problem where over half the AB students got 0 on this. So they brought it back to make sure that students were getting this. So it's kind of a tricky problem, but once you get the hang of it and understand some of the basic concept, it's really not that bad. So let's go ahead and do this. The previous year, I believe it was the trash, garbage pile. So we have a rate, keyword. Birds gain weight. Now, they're going to tell you it's proportional to the difference between his adult weight and his current weight. That maybe is there to confuse you a little bit. That just tells you that the rate, the derivative, is related to the weight of the adult and the baby. So that's actually given to you in this formula here. So let me explain that. dB/dt is the rate of the baby's weight, the rate of its growth of weight. Proportional just means it's equal to a constant times the difference. The 100 minus b is the difference right there between the adult and the baby. And the proportionality, the constant, is the 1/5. So all that is to say, here's the equation, that's the information. So at time t equals 0, we know the bird weighed 20 grams. I want to write that down as part of my information. When t is 0, b is 20. We could do grams here. And they actually restate that again right here. So I'm going to write that also in that way. In other words, b of 0 is 20. That's just the initial condition. So part A, is the bird gaining weight faster? So we need to determine what that means. When it weighs 40 grams or 70 grams. So gaining weight faster, that means the change in its weight as time changes is greater. Or in other words, dB/dt is the derivative greater at 40 or greater at 70. Well, the nice part, they give us the derivative. So we need to find the derivative at b equals 40. And we have to find the derivative at b equals 70. So again, dB/dt is how fast b changes as t changes. So it's just a rate of growth. So plug in 40 into the formula, and we get 1/4 of 60. Plug in 70, and we get 1/4 of 30. So which one's greater? Clearly at 40. So you can't just say the answer is 40. You have to explain why. So you'd have to say the bird is gaining weight faster when b equals 40. Now here's the justification. Because dB/dt at b equals 40 is greater than dB/dt at t equals 70. That is all you need to write on that. Let's go to part B. So the first thing they ask us for is to find the second derivative. This is where we have to be careful, and we have to realize a couple of things here. So b right here, that's our function. And then t down here, that's giving us our variable. It's important to recognize what is a function, what is a variable. So when we're finding the second derivative, I'll do b right here. Let's start with db dt. So we have to find the derivative of this part, and that will give us the second derivative. Now here is the tricky part. The 1 over 5 is a constant, so all we're going to do is copy that constant down. And now we need the derivative of 100. That's just 0. Now here's the part that you have to be careful. The derivative of b is not 1. Again, b is our function, not our derivative, or not our variable. T is our variable. If this were a t, the derivative would simply be 1. But since b is our function, this is a function. To take the derivative of that, by definition, it is db dt. So therefore, the second derivative is 1/5 in the opposite of db dt. Now, they want the answer in terms of b, if you read question b. So we have to replace db dt with what it is. And there is our second derivative. So that's the second derivative of b with respect to t. But we're not finished. Remember, reread the question. It says use db dt, or second derivative of b with respect to t, to explain why the graph of b below cannot resemble the following graph, or explain why the graph of b, the actual graph of b, cannot be the graph below. So we have to use a second derivative, so we have to think to ourselves, what does the second derivative tell us about the original function? And we should think concavity. And so we see this graph that's given here. It's concave up down here, concave down here. So we have to think, this graph is wrong. They tell us it's wrong. So we need to look at our second derivative and figure out why it's wrong. So clearly, it's not going to match up. So here's one question. What do we know about b? Because b is going to tell us what the second derivative is. So if we look back in our original statement up here, we know b starts at 20. When the baby's born, it weighs 20 grams. And we know when it's an adult, it weighs 100. And we get that because right here it tells us the difference between the adult weight and current weight. The adult weight is 100 because that's what the formula has. So we know that b is between 100 and 20. If that's true, therefore, if we plug that in here, the second derivative will always be negative. If that were true, b should always be concave down. So therefore, b is always concave down. But if you look at the graph, clearly it's not always concave down. But the graph is not always concave down. All right, that is part B. We have one more part to do, part C. They're telling us to use separation variables. They don't always tell you that. So you have to recognize when to use separation variables, and they give you the initial condition. So let's start with the original problem. dB dt is 1/5 100 minus b. All right, if they told you to find the solution or to solve for b, if that's all they said and they didn't ask you to use separation variables, how are you going to recognize that? So you have to realize, again, b is your function. T is your variable. Since that is not t, you can't just simply take your standard antiderivative. You have to realize that I need t's on the right side, and I don't have them, but I have a b, so I have to separate it. So we're going to divide both sides by 100 minus b. And we're going to multiply both sides by dt at the same time. So those will cancel there, and these will cancel here. And this becomes dB over 100 minus b equals 1/5 dt. All right, you get 1 point just for separating it out. Now we need to integrate both sides. This is actually one of the hardest separation of variable problems you will see on an AP test, because you have a u sub and some weird things are happening. So this down here needs to become my u. And then du will be minus 1 dB. So we need this right there. We don't have it, so we put a -1 here. We have to put a -1 in front, which makes it multiplying by 1, which doesn't change anything. Now we're going to sub everything out, or in. So we're going to get -1 integral. Let's do that black. -1 integral. And the red part on top is replaced by du, and the bottom is replaced by u. The antiderivative of 1/5 is just 1/5 t, and I need my plus c. And the left side, the antiderivative of 1 over u is just ln absolute value u. I need to replace u with 100 minus b. All right, this is very ugly, and I need to get rid of the ln. So I need to use an exponential function base e. But we have a problem. If at this point I try to do this and make the ln cancel, I can't, because this -1 is in the way. So before I do that, I need to clear out that -1 by multiplying both sides by -1. And that'll make it prettier. Now I can e both sides. Let me get rid of all this stuff here. All right. So these are just going to cancel out, leaving that. Now the right side I'm going to split up. Like that. Now I'm going to do another little trick here. I'm going to let k equal e to the minus c, because e is a constant and minus c is a constant, so those combined is just a new constant. So I'll just rename it as constant k. And then on the left side, we're going to do something. Since b is always between 20 and 100, 100 minus b is always positive, so I don't need the absolute value. So on the left side, I get that. On the right side, I get k. Now I need to solve for k and then solve for b. Let me create more space here. We were given right here, b of 0 is 20. So we know b of 0 is 20. If I plug that in, 100 minus 0 equals k. Ooh, back up. That's not 0. This is b. 100 minus 20 is ke to the 0 power. So k is 80. I'm going to plug that value in for k. Now I just isolate b. And that is my final answer.